Hey guys, my name is Sibusiso, but you can also call me Coach Sbu. Welcome to the Maths Buddies channel. In today's video, I'm going to be sharing with you methods on how you can solve financial maths. So if you're a new viewer, please be sure that you can leave any topic that you would like me to do so I can be able to generate methods for that topic. So without wasting further time, I'm going to go straight into today's video. Now in today's video, we're going to be looking into methods on how you can solve financial maths. But the first thing that you need to know about financial maths is that it is a theoretical topic and a practical subject, which means in each theory, or because of this theory, there's going to be keywords that are going to guide you to answer the question. So let's go ahead first and look into 7.1 to see if we have any keywords that we have or that we can get the. So the question reads as follows. Exactly 6 years ago, Lisejo bought a new car which is worth 1/3 of its original price now. If the car depreciates by a fixed annual rate according to the reducing balance method, calculate the annual rate of depreciation. So here, as you can see here, we're talking about what? We're talking about a depreciation that is under the reducing balance method. So this means first things first, we're going to be using a depreciation formula. Right? Now in this depreciation formula, you need to understand that A here is the value after period, and then P is the value before, right? And then I, it is the interest, and the interest, it is normally added, it is normally calculated. In general, it is I over M, right? Where M, it is what? It is where M determines how many times, right? The interest is added in a year, but we're going to talk about that later. And then N here, it is not the number of years. Please don't ever say N is a number of years. I know that you were told that it is a number of it is a number of years, but that was a lie. And it is the number of times, not the number of years, but the number of times interest is added, right? And then later, when you talk about present value and future value, it is basically approached in a different way, but still it is still talking about the number of times interest is added, right? All right, so here depreciation, it means the money after, or the value after, is always going to be less than the value before. So before, now here, let's say this car, it was costing X, right? Now they're saying now 6 years later, right, this car is worth 1/3 of its original price. So this means A, it is 1/3 X, right? Now this has happened for 6 years, but then now here N is calculated by saying years multiplied by M, right? So M here is 1 because it is an annual rate that we're talking about here. We're talking about an annual rate. So this means now here N is going to stay as 6, right? It won't be 6 years, but it will be 6. That 6 came from 6 years multiplied by annual, which is M is 1. Number of years in the years is 1, hence we're saying 6. Then from here, we're just going to substitute and then solve our interest, right? Which is what we need to find here. So here, we're going to have 1/3 X, which is going to be X into 1 minus I. And then this is going to be into 6. And then as you can see here, the X and the X, they cancel each other, right? And then we're going to be 1 minus I into 6. And then the 6th root of that, let's see, 6th root of that gives us, let's get the calculator. So 6th root of 1/3 is going to be 0,A3 A326 A31 777, and then the other side is going to be 1 minus I. So I'll take the I cross and then take that decimal number to this side, 26 A31 777, and then I is going to be, so I'm going to press this in a calculator, and I'm getting 0,1673 168 223. then I multiply this by 100, and then I here it is 16.73%. That's easy. All right, now let's go ahead and look into the second question. Right, now if you remember earlier, please keep in mind of what I've said here about the interest and the n, right? So here in this second question, again, it is going to be more theoretical, and then we're going to need to find keywords to see what is happening here. So let's go ahead and read the question. So the instructions goes as follows. Bonang is granted a home loan of 650,000 to be paid over a period of 15 years, where the bank charges the interest at 11.5% per annum compounded monthly, and she repays her loan by equal monthly installments starting 1 month after the loan was granted. All right. Now here, the keywords here are what? Are a home loan, right? So Bonang got a home loan. So this means now this money of 650,000, right? It was the money that was given to her in a present tense. So this means now here we have a present value of what? Of 650,000, right? So how did you know that it was a present value? Because a loan, whenever you're getting a loan, you're not gonna get a loan tomorrow. If the minute you get approved on a loan, you're gonna get it right now. All right, so now here then it says this loan it needs to be paid over the period of 15 years. All right, cool. Now here they're saying that the bank charges it charges interest of 11.5% per annum, but then it says compounded monthly, so it means we need to divide it by 12. This means the compound here it is 12. Now notice something here. Notice that here the only thing that I wrote it is this value and the interest, right? But I didn't write what is n. Now the reason why I don't write what is n is because in a present value, according to it depends on what the question is asking you, right? So if we're talking about the present value itself, right? So let me write the present value first of all, the formula. If I'm writing the present value itself, I need to understand that there are things that changes in that, right? Because now here present value, it means now it's the money that you've been loaned or you have currently, right? So now here the PV, it is the value in present. You need to understand that first, right? And then X here, it is the payments, right? It is the payment installment, right? I will just say payment, and then I here, it is still interest. And then as you can see here, the interest here, we always take the interest that you've given per annum, and then you divide it by the compound that you'll be that the interest will be added in a year, because remember m means how many times interest is added in a year. And then n here, it is the number of times, right? Or the number of times that you still need to pay, right? Or the number of payments that you still need to make. Because here the money is yours, and then now n here, it is counted as the amount of times you still need to pay, right? So they look at it as, oh, okay, we gave you this amount, and then now you have a period of 15 years, and then the end day they'll be like, okay, every month you're paying this much, right? Every month you're gonna be paying, so you have this number of times where you'll be paying this X amount of money, right? So that is why n here it is perceived as the number of payments you still need to make. But now in the future value, just to share everything, in the future value, n is not regarded as the number of payment that you still need to make, but it is regarded as the number of deposits that you've already made. You need to be very careful with that, right? N in present value is not the same as n in the future value, right? Same as x. X is what? It is the deposits that you're making, and then FV, of course, is going to be the values you're going to be having in future, right? So just to be clear with that one. All right, now that that is out there, we're going to go there now, look into the question, right? You can see now why I didn't write that n and say it is 15 times 12, because it depends on the question. Now let's read this first question. So the first question says, let's calculate Bonang's monthly payment. So now here we want to calculate Bonang's monthly payment, given that Bonang pays the money that she owes according to the contract, right? So this means now here we can then say now we need to know that n, if Bonang pays for like a period of 15 years, that means the payments that Bonang is going to make is going to be for 15 years, right? And then we're going to multiply this by 12, which will give us 180, right? You see, now I know that n now is 180, so I'm going to be working with that, right? So what am I going to do now? I'm going to be calculating my x. So that is going to be the formula that we're going to use, right? So another method that I like to use when I'm doing present value and future values is to first see what is it that I'm trying to find. Here I'm trying to find x, and then what they need to do is I need to first isolate it before I can substitute. So here it means I need to multiply this I there to get I times PV, and on the right side I want to be left with 1 plus I to minus n, like that. And then I'm going to be dividing by 1 minus 1 plus I minus n over 1 minus 1 plus I minus n, and then this cancels with that, and therefore my x is going to be I times PV over 1 minus 1 plus I into minus n. Now please, if you're going to be doing it my way, please make sure that you show everything here, because it counts as marks, right? You get marks for this. So 11.5%, now I'm going to be substituting, times PV is 650,000, 1 minus 1 plus I is 11.5% over 12, and then this is for payments that she'll be making is 180 payments. All right, then now we're going to go straight into our calculator. So opening our calculator, we're going to get, let's see, 11.5% over 12, and then times 650,000 over 1 minus 1 plus 11.5% over 12 into minus 180, sorry, to the power of minus 180, like that. Alright, so 7593 comma 23, 7593 comma 23, and that is the value of x. Now this is the number of payments, this is the amount of a payment that Bonang will be making if Bonang doesn't make any changes, or if she continues to pay that amount, right? For 15 years it will be that amount, right? Let's go ahead and look at the second question. Now in the second question, let's read this. So it says, now how long will it take her to finish the repayment of the loan if she decides to increase her monthly installment to 9,000 per month after 5 years? All right, so here Bonang has decided that she will basically she wants to change her monthly installment, right? So if she wants to change her monthly installment, remember, banks are so smart. Everything that they do, everything that you do, it means it's like a penalty, right? They want to give you a penalty because they still want to win. Even if you were thinking that by you paying 9,000 now there's going to be a difference, the bank, they are so smart, they still see it as an opportunity for them to make money for themselves, right? So here, this then means, now here, in order for us to understand how long will it take her, the first things first is, what we need to understand is to understand how much was the, right, or how much was the outstanding balance when she decides to do what? To change her payment, right? To change her payment to 9,000. So the first things first now is this. Here we know that previously Bonang was paying 7593,23, right? And then now we need to understand that after the 5 years, what is it that was left, right? Which means, in order for us to understand everything, we need to know that here we know that Bonang was still left with how many years? With 10 years of payment, right? So it means now when she decided to change his installment, she decided after the 5 years. So now here I need to first know what is it that was left. So that is basically what is it that we're going to calculate first. So 11.5% over 12, like that. And so to basically to calculate the outstanding balance, we're going to be using PV, right? Because I mean, we're still trying to understand what is it that is left, because this PV is a value in present, right? So here what we're going to do then is we're going to use our formula 1 minus 1 plus I to minus n over I. Now this will help us to first calculate the money that was left, or that she still needed to pay, before we can then use that money to then calculate how long will it take her to pay the rest. So as you can see here, 11.5% 12. Now going to the calculator. So going into our calculator, we can see that this is going to be 7593.23 into 1 minus 1 plus 11.5% over 12, and to the power of minus 120 over 11.5% over 12. Alright, as you can see here, so she still needed to pay 540,076, 53, right? So now from this is what? This is the outstanding balance, right? The outstanding balance. And then with this outstanding, what we then do is we then calculate her monthly installment, right? So how long will it take to finish her repayment, given that now she changes her monthly installment? So this means now again, after calculating this, we're then gonna use the formula that we got there to then calculate n. Alright, so now we're going to be isolating n. So to isolate n, just like I said earlier, I like to first work with the variables as they are. 1 minus 1 plus I minus n. This is minus n like that. And then first of all, here I'm dividing by x, and then this cancels with that. Then I have I times PV over x, which is equals to 1 minus 1 plus I into minus n. And then from there, we take this part, we bring it this side, 1 plus I to minus n, and then this is going to be 1 minus I times PV over x, right? And then from there, and then we see here the previous part, we had what? We had 1 plus I into minus n as 1 minus I times PV over x. And from here, I want to have the exponent. So exponent is going to be the log base, which is 1 plus I, and then the constant here is PV over x, right? And then from here I can see n is minus log 1 plus I into 1 minus I times PV over x. Alright, now from here, what do? I then substitute. So by substituting, it's going to be 1 plus 11.5% over 12 into 1 minus 11.5% over 12 multiplied by, let's see, 540 and 076 comma 53. Now you're wondering what is going to be x. Remember x now, since we left with what, we will still understand how many times how long we left. X is going to be 9,000 because now she decided to pay 9,000. So we want to press this in our calculator and see what we get there. Alright, let's see. Let's open this up. So we're going to say minus log. So it's going to be minus log. So it's going to be 1 plus 11.5% over 12. Close that. Then inside that we have 1 minus fraction, bracket fraction, 11.5% over 12. And then we close that. And then I say 540,076.53 over 9,000. Let's see. So it's going to be 89 comma, so this is n is going to be equals to 89 comma 7341,569. all right, so what does this mean? So basically this means now here the whole number here, which is 89, this means now the 89 is going to be the what, the full amount of 9,000. So the full amount of 9,000, she'll be making it 89 times, but then the last amount is going to be less than 9,000. So meaning she'll still make a payment on the last payment, but it will be less than 9,000. Therefore this means now the payments that she'll make are going to be 90 payments, right? All right, so that's basically how we get into the how long type question, right? Now the 7.2.3 is then asking to calculate her final or her last payment, right? So the final payment, to calculate it, what we first do is we know that it is going to be the outstanding balance, or the remaining payment here, because here we see that here Bonang had 89 full payments, but then there was that 0 point that was left. Let me just write it here. That's 0.7341,569 type of a payment. So that is the one that we're going to be basically calculating here. So this is going to be the outstanding one. So to do this, we're going to be still using PV, but then this PV we're going to multiply it with an interest, because this interest, this is a charge that the bank is giving to Bonang for what? For changing their monthly installment. Now how do we then do this? This then means now in our PV, n is going to be 0.7341,569. remember we said n is what? We said n is the number of payments that you still need to make. So she still needs to make a 0.7341,569 type of payment here, right? And then here, what is I? I is still 11.5% over 12. Now because of we're using the present value, the x is still going to be 9,000, like that. And so we're gonna then calculate. So the final payment, all right, is going to be the formula of the present value, 1 minus 1 plus I into minus n over I multiplied by the interest that the bank charges. Right now the bank charges, let's see, 9,000. 1 minus 1 plus 11.5% over 12 to minus 0, 7341,569, right, over 11.5% over 12, and then we multiply this by 1 plus, okay, I don't have a space there, let me just put it in front here. It's the same thing, 1 plus 11.5% over 12. Yeah, it's the same thing, but it's just that I didn't have space, right? If you want to see it to be the same thing, we can still calculate it, as it is right here. I can still say 1 plus 11.5% over 12, right, times, now to make this fun, while I'm writing it this way, do it the other way around to see if you're gonna get the same answer. 9,000 into 1 minus 1 plus 11.5% over 12 to the power of minus 0.7341,569, and then we say over 11.5% over 12. Let's see. There we go. See the last payment, like I said earlier, it is less than the 9,000, and it is 6,615,78 cents, and that is how you basically answer the final payment. And that's all I got for you today, guys. If you like the video, please make sure that you leave a comment and also share with your other friends so that they can basically learn how to basically calculate the outstanding balance and also how to calculate the final payment. Now the idea here is that whenever you're using the present value, you need to understand the significance of n, right? The significance of n, it is the number of payments that you still need to make. So whatever that you do, whenever you're substituting here, you still need to always, or you should always ask yourself, all right, if I'm doing this, how many times or how many payments do I still need to make? And then you're gonna put in that number there, right? And that's all for today. I'm gonna see you on to the next one, where I share about the theory that is on probability, which is a topic that most of people they cringe in. So I'm gonna be sharing there some keywords as to how you can basically answer to that one. All right, cheers then, bye for now.